Hi, we continue with calculus. We differentiate equations today with the fractional and the negative power. So before we do our examples, I would love us to revisit indices just to remind us how we can express our equation in a way that's differentiable using the formula. So we have the square root of x is equal to x to the power half, and 1 over x is the same as you having x to the power negative 1. So whenever you have x as a denominator, you push it up, you maintain what you have on top as a numerator, which is 1. So 1 times x, the power here is positive 1. When it comes on top, the power becomes negative. We apply the same rules in 3. So 2 is on top, you leave it as it is. You push the x on top, the power becomes negative. Then this 3 over the square root of x to the power 3. Remember that the square root is the power half. We already have a 3 here, and indices allow us to multiply the powers. So 3 times half will give us x to the power negative 3 over 2 when we push the x up. So we go in our equations to differentiate 1, 2, and 3. So differentiate y is equal to the square root of x to the power 3. So we express y in a way that's differentiable using our formula. dy dx is equal to a times n x to the power n minus 1. So y is equal to x. So 3 over 2, our dy dx then becomes the coefficient times the power. So it's 1 times 3 over 2, which is just 3 over 2 x, and then 3 over 2 minus 1, because when differentiating the power reduces by 1, we're going to have 1 over 2, which is the same as 3 over 2 square root of x. So we have differentiated y is equal to the square root of 3x to the power 3 after expressing it in a much more friendly form. We go into 2. So what we have on 2 is y is equal to the cube root of x, which can be expressed as y is equal to x 1 over 3 minus 4x, and we bring it up, that's minus 1 over 2. We get our dy dx. The coefficient times the power is just 1 over 3 x. 1 over 3 minus 1 will give us minus 2 over 3. Negative times negative will be a positive, and 4 times half is just 2 when you have x. When you do 1 over 2 minus 1, you're going to have minus 3 over 2. So again, we can write it in a much proper way without the negative powers. We're going to have 1 over 3 x to the power 3 x squared plus 2 over the square root of x to the power 3. Would have differentiated our 2 and had that one as our derivative.
Okay.
Then with 3, we have s is equal to 3 over t squared. So I've used s and t because sometimes we get too accustomed to just using the same letter over and over again. You see a different letter and you feel you haven't learned. So whenever you have different letters, just express your dy dx in terms of the letters that you have. So before we do that, let's rewrite this one in a way that can be differentiated by the formula. So s is going to be, we keep the number that's on top of the numerator, which is 3. We push the t up, then introduce a negative sign to the power. So to get our ds dt, we multiply the coefficient times the power. So 3 times negative 2 negative 6t, negative 2 minus 1 will give us minus 3, which can be expressed simply as 6 over t to the power 3. So on number 4, we have something similar to 3. It's a fraction as well. Y is equal to 3 over x minus 1 over x squared. So y will be expressed as 3x minus 1 minus x minus 2. We get our dy dx. We get negative 3x minus 2 plus 2, negative and negative, then x minus 3, and our final answer then minus 3 2 over x to the power 3 as our dy dx. So we may also try out to differentiate y is equal to 1 over the cube root of x plus 2 square root of x minus 1 over x, and show that your final answer gets to negative 1 over 3 cube root of x to the power 4 plus 1 over the square root of x plus 1 over x squared.